Part B. So let's start by plotting the points that they've given us. -4, 3, 0, 0, and 3, 4. So that's F, this is E, D. When I connect my dots, here's my triangle. Oops, I labeled this wrong. This one's F. This one's E. Sorry about that. So they tell us here that angle F appears to be a right angle. So we would check using slope. The slope of DF would be 0 minus 3 over 0 minus -4. So that's -3 over +4. The slope of EF would be 0 minus 4 over 0 minus 3 and this is -4 over -3, which is +4/3, and they are opposite reciprocals. So angle F is 90. Now we're going to find the side lengths using distance formula. DE, that's the segment here, is 3 minus -4 squared plus 4 minus 3 squared. So 3 minus -4 is 7 squared is 49 plus 1 squared is 1. So I have square root of 50. And then they go through the process of simplifying the radical just to evaluate it anyway. I don't see any reason to do that. Let's just take the square root of 50 and get 7.07. Now we're going to find the length of DF. That's this segment here. And that's these coordinates up here. So DF is 0 minus -4 squared plus 0 minus 3 squared. This is 4 squared is 16 plus -3 squared is 9. 16 plus 9 is 25, and the square root of 25 is just 5. Finally, I'm going to find the length of EF. That's this segment here using these coordinates. And that is 0 minus 3 and 0 minus 4. So I end up with the same 25 and 5 there. In order to find angle D, they're using the sine ratio. So angle D is the inverse sine of EF over DE. The length of EF was 5. The length of DE was approximately 7.07. So when I take 5 divided by 7.07 and I take the inverse sine of that, I get approximately 45 degrees. Angles D and E are complementary, so angle E will equal 90 minus 45, which is also 45. How does the given information determine which inverse trig ratio you should use to determine an acute angle measure? We've talked about this before in class, that the combination of side lengths i.e. Opposite adjacent hypotenuse determines what trig ratio to use. Finally, one more example like that. Take the points and plot them. 3, 5, that's J. K at -3, 2, and L at 5, 1. Oops, not there, silly. There. In this diagram, angle J looks like it's a right angle, but you have to verify it. So let's find the slope of KJ. So that's 2 minus 5 over -3 minus 3. Remember, y minus y over x minus x. So that's -3 over -6, which reduces to +1/2. I find the slope of JL. That's these 2 points. 1 minus 5 over 5 minus 3. That's -4 over 2, which is -2. And these are opposite reciprocals, so yes, angle J is my right angle. Now we're going to use distance formula in order to find the lengths of the sides. So JL is 1 minus 5 quantity squared plus 5 minus 3 quantity squared. And hopefully you'll forgive that I did y's before x's. It's kind of a habit after doing slope. It doesn't matter since I'm adding them. And for example, 2 plus 3 is the same thing as 3 plus 2. Okay, so hopefully that doesn't mess anybody up. All right, so I'm simplifying this, and I get -4 squared is 16, plus this is 4, so 16 plus 4 is 20. So the square root of 20 is approximately 4.47. JK is, I'll do it right this time, -3 minus 3 squared plus 2 minus 5 squared, and that's the square root of, this is -6 squared, which is 36. This is -3 squared, which is 9. 36 plus 9 is 45, and the square root of 45 is approximately 6.71. Finally, the length of KL is the square root of 5 minus -3 squared plus 1 minus 2 squared. This is 8 squared is 64 plus -1 squared, which is 1. So this is square root of 65, which is approximately 8.06. Finally, let's find an acute angle measure. I'm going to find the measure of angle K. And because I know all 3 sides, I can use any trig ratio I want. I'm going to use the tangent of K. So tangent is opposite over adjacent JL was 4.47. JK was 6.71. So the measure of angle K, let me zoom out here, is going to be the inverse tangent of 4.47 over 6.71. That's approximately 34 degrees. Measure of angle L is 90 minus 34.